Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is ingrit harmaini. I'm from biology education in University Muhammadiyah for Dr. Hamka. In this video, there are 2 points which I will explain about the evolution of population. The point 1, genetic variation make evolution possible. 2, theory Hardy-Weinberg equilibrium. Okay, so I explain the first point, the evolution of population. The first point, genetic variation make evolution possible. Genetic variation make evolution possible. 1. Variation inheritable traits is a prerequisite, so that just means that there has to be a difference in the traits that you can be passed on from parents up to offspring in order of evolution to even happen otherwise. If everything was identical, like let's say the coloration or something, and suddenly the environment, but then suddenly that now coloration is just advantageous and everyone identical, well then all of the organisms are going to get taken out because suddenly they're completely in that way. The next number 2, Mendel's work plans provide evidence of these great heritable units that called gains. So now we know that gains are actually these heritable traits that we're talking about. Next point, theory Hardy-Weinberg equilibrium. Is the Hardy-Weinberg equilibrium its name of a mathematician and equation, and is that a population allele and genotype frequency are contained unless there is some type of evolutionary force acting upon them. A remainder from or actually a population, in this case in a group of organisms that are all the same species and can breed with each other and have totally offspring. However, there can be variety among a population as they are not of each other, but based on Hardy-Weinberg equilibrium, their population allele and genotype frequency would remain constant if no evolutionary force acts upon time. If we have this fork here, assuming they are all the same species in the example, but there are some differences. In our simplified example, some of the frogs are light green and some are dark green. We are going to ask a sample genotype in the example. All the frogs in the population will either be GWG, GWG, or GWG. There is also an allele frequency in our population. We are going to say here that 16% of a frequency of 0.6 of the allele are G, 40% of the frequency of 0.4 of the allele are G. Notice the percentage at up to 100% and the frequency at up to 1. Now, to be in Hardy-Weinberg equilibrium, we have to 5 assuming patterns. 1. No selection. 2. No mutation. 3. No migration. 4. Large population. And 5. Random mating. If the 5 are matched, the population is in Hardy-Weinberg evolution is not occurring at that locus, and the allele frequency will remain the same over time. Thank you all who have watched my video about evolution of population. I hope the video is useful for you. And Assalamualaikum warahmatullahi wabarakatuh.